Okay. Good morning, everyone. Thank you for coming to this morning's presentation on effective project management of LabVIEW projects. My name is Paul Herrman. I'm Senior Vice President, General Manager with Surtech. We're a Gold Alliance partner based in Kansas City and Albuquerque, New Mexico.
My name is Ryan Smith. I'm a Senior Staff Engineer with Surtech, and I'm a Certified LabVIEW Architect, Certified LabVIEW Embedded Systems Developer, Certified Test Stand Architect, and a Certified Professional Instructor for National Instruments. So I get lots of flair. So I'm going to be presenting today on the LabVIEW aspects of project management. Paul's going to be taking more of the program manager or the management side. How many of you in here are more on the technical side? Okay, it looks to be maybe about half. How many are on the project management side or the management side? Okay, how many are on both? Yeah, okay. Yeah, we see that a lot. So that's kind of how we're going to approach the session. And now, I like to keep an open dialogue. So if you've got questions, stick up a hand, yell at me, say something. I feel like if it's more of a dialogue, we all learn something. We don't know all the answers. We're going to give you some examples of what we've done in the past. So yeah, if you've got questions, feel free to ask, and we'll go down this path together.
So our discussion this morning will take place in three main parts. We're going to go over the project plan, the work breakdown structure, setting up your project and planning for it. I'll cover that part. And then Ryan will discuss the LabVIEW architecture concerns. And then we'll talk about monitor and control communication, the actual implementation of the project. So when you set out to define the project, you're working on that project plan, you want to identify objectives and assumptions. What is the big picture of your project? What are the items that I have no control over? Sometimes there's customer supplied material or long lead time items, equipment, specialty connectors that are hard to get. Try to identify those items up front. Discuss the materials and resources that you need. And then you really want to focus on the deliverables and the deadlines. Know what it is that you have to get done. So for example, make sure that you've got solid requirements. Sometimes this is a challenge because the customer has a vague idea of what they want, but not strong details. So sometimes you have to write those up. Also, make sure that your stakeholders have buy-in on the project. You want to let them know what your plan is, where you're headed, and make sure that you're in alignment with the stakeholders' goals. These different expectations can lead to frustration at the end, so try to get those identified early on in the project. Know when it needs to be done. Try to have a very clear objective for what project completion. And as we talk about the work breakdown structure later, we'll talk about ways to meet the timeline, the deliverable, on time. One other thing to consider, and we get this a lot with Surtech, working in the aviation industry, where we have DO 178 or DO 254 guidelines that we need to, regulations we need to meet. Be aware of government or industry regulations that you need to meet for the project. So defining the project, again, focusing on the requirements, and a lot of times there are nice to have items. Many times these come up as the project is developing. Once your customer sees a certain item, they say, well, can we also have this or have that? Sometimes it's a small change and it's easy to implement, that's fine. But other times it takes a day or two or more. That's scope change, and you want to identify that and get approval for that. There needs to be boundaries on how scope changes are approved. So many times an engineer or a manager that you're working with will say, oh, I approve that. Yes, go ahead and implement that. But it's purchasing that has to sign off on it. they're the ones that authorize payment, especially with a fixed price arrangement, business arrangement for a project. So the whole challenge are the triple constraints of cost, schedule, and quality. And many times, as you're working to meet the schedule deadlines, if you're running a little bit behind, maybe you add some more resources to the project and the cost goes up. Or sometimes the quality of the project might suffer. Actions or functions may be de-scoped. And so that might be a way to try and meet the timeline, the deadline. So our goal with today's discussion is to help all projects meet the cost guidelines, get it done on time, and with a full feature set, with a full set of quality implemented.
So I've got a good example here. Paul talked about the nice-to-haves. We got some requirements from a customer. Did a really good job of kind of laying out what the scope of work was. But then they put a second document in there that said, which requirements are we going to implement? So yes, no. But there was also nice-to-have. And, you know, as a developer, you know, first of all, you got all these requirements, and you see those nice-to-haves, and you're really tempted, oh, well, I could just sneak that in. But it wasn't marked as yes, you have to do that. So, you know, you kind of have to keep that in mind. You know, as Paul said, sometimes when they're little, yeah, we can do that. But, you know, really you have to stick to what the agreed terms are, what the agreed requirements are.
In past projects, we've had an issue with the user interface requirements. We had one project, there was practically no definition about the user interface, and so we created what we thought would be a solid, robust user interface. When we delivered it to the customer, they said, well, where's this, and where's this piece, and where's that? And so it was a frustrating experience. So ways that you can identify the user interface requirements is another piece of defining the project. Also, any calibration needs, how you're going to store the data results, what's the reporting format. These are all things that you can identify early on in the planning stage.
Have you dealt a bit with nice-to-haves in terms of feature creep or releasing or other ways to help manage how nice-to-haves actually roll in? Because you may get bugs or unintended workflows because of it.
Yeah, so the question was, you know, how do you handle feature creep? How do you handle these nice-to-haves? We talk a little bit about that a little bit later, but, you know, I find that if it's really nice to have as a developer, you're like, wow, you know, for just a little more effort we could put this in, talk to your customer. You know, come to an agreement. Put in a change of scope or de-scope something else, you know. But again, you got to get approval up front. And I'll add something, you know, we talked that it's really important on fixed price because you don't want to have to eat that work, depending on who your customer is, you know, whether it's an internal customer or an external customer. But it's actually very important also on a time and materials project because there's a set of required work that has to be done according to your contract, okay? And if you get a bunch of nice-to-haves done and you don't have the core functionality done, you haven't met your contractual obligation. So even though they kind of agree, they say, oh yeah, don't worry about that, let's do this instead, you got to get that in writing. You got to get approval to do that.
Got a question. Not necessarily the nice-to-haves are easy to implement. Sometimes the nice-to-haves may be quite difficult to implement.
Right. So the comment was that nice-to-haves aren't always easy. Sometimes they're quite difficult. And again, that's really where you make that discussion. But if you can prove the value of that nice-to-have, you know, a lot of customers will be like, yeah, that makes a lot of sense. We need to do that. So yeah, that's a good comment.
And it's appropriate to push back and say, I definitely want to, I can implement that, but I need to have the scope change. I need to have written authorization to implement that.
Definitely.
And the other point I'll make is it's important for the whole team, all the team members, to know what the definition is, what the scope of the project is, so there's a border around what we're doing, what's included, and what isn't. Because many times it's not the program manager, but it's other people on the team that are faced with these gray issues of, is it in scope or out of scope? So as you're working on a project plan, Certec likes to use a work breakdown structure where you list out significant details and milestones. And this helps lay out the plan, all the details of what you're going to incorporate. It starts off at a high level, conceptual design, detailed design, fabrication, software, integration of hardware and software. But as you get working on those different phases, then you start filling in some of the details about actual work tasks, and you break those down. You also want to be concerned about risks and identify contingencies. So again, I talked about customer supplied material. If they're not going to get you the unit that you need to test or some part of the system, have a plan to work around that risk and have a contingency plan. And as you create this work breakdown structure, each task, estimate on effort, not on calendar time. Don't just say, this is 3 days work, but really try to focus on how many hours of effort you think the work is.
Well, and I'll just kind of throw this in there too. So keep in mind that hours worth of work changes a little bit depending on the year. You know, you could have holidays, you could have vacations and things like that. So you might remember that, especially on a long project. You know, if you say, oh, we'll have that done by, September 15th. Well, did you take into account that there might be summer vacations? Your developers may be out, there could be holidays. So once you figure out what that effort is, you might just, the number of hours may not equal the calendar end date.
I think overlooked tasks are a contributor to projects not being completed on time. So we're focused on getting the software and the hardware all integrated, getting everything ready to release, and it's, oh yeah, we forgot about an operating procedure, a calibration procedure, a test plan, maintenance procedure. It's all these things were listed out in the contract early on that, oh, we forgot about. So having those listed in the work breakdown structure help ensure that you don't miss those items. One other thing to consider in the work breakdown structure is if you have rework items, you'll want to have time to test that out and make sure that you've got that reviewed and tested and that it works properly. So as we talk about the work breakdown structure, we talk about listing all the work tasks that need to be completed. So sometimes you could use Microsoft Project. We use that sometimes. Sometimes we use something called Smart Sheets. It's a kind of a hybrid between Excel and Project. It's much cheaper. It's an online tool. But you can identify the main tasks and the subtasks, and ultimately what you want to identify is the critical path. Many times tasks can be completed in parallel. Bring somebody else on and we can get things done in parallel, but there will be a set of tasks that must be done in series, and that will become your critical path. So those items get your highest attention to make sure that there aren't delays and they get implemented on time. You want to decompose these tasks, I mentioned this earlier, to inch-pebble granularity. What I mean is just breaking down those big rocks into smaller pieces. So you've got a software driver you're going to write. So there's develop the code and test it out, peer review, documentation, all those pieces that go into that. Maybe you're planning on the sheet metal for the physical part of your test system. And so what drawings and what hardware do you have to have in place to support the sheet metal schedule and coming in to be ready for when you're ready to fabricate and assemble the whole system. You want to make sure the requirements are the basis of the work breakdown structure so that you're covering all the items that need to be worked on in the project. So one thing that we use is a compliance matrix where we'll list out all of the items in the statement of work for the project. So you list all those items and then, okay, where are they being covered? And you make sure that you've got them somewhere in your work breakdown structure so that you got coverage and you don't get to the end of the project and oops, we forgot to do whichever part.
Jim.
I had a question. You mentioned inch pebbles.
Yes.
Do you have guidance on the maximum number of person days or person hours that a task may have to be allowed in the work breakdown structure before you ask the estimator to break it down further?
Okay. So the
So,
que-
so the question is how do you know what granularity to go down to? You know, we talk about inch pebble. What is inch pebble? And I'll answer it like this, and I'll answer it kind of in a vague way. And we're going to talk about software development lifecycle. It depends on what kind of software development lifecycle you're doing. So I'll get to that in just a little bit. Is that fair? Okay.
it sometimes depends on the size of the project also.
Absolutely, sure.
But the hope is that the whole team will be plugged into the activities defined in the work breakdown structure. Our intent is not that it's a document that you create and then set aside. It's a living document. You visit it daily, weekly, you have team meetings, daily scrum meetings or weekly team meetings. And you go over, and you find out, Ryan, where are you at on this task? Okay, I'm 50% complete, or I'm 75% complete. And you track the progress of each of those items.
So Paul mentioned tools to use for that. There's lots of tools out there. You know, we specifically mentioned Project and Smart Sheets. But you know, it doesn't have to be complicated. It could be an Excel spreadsheet. I know, I said it. It could be an Excel spreadsheet. Spreadsheets have a tendency to get abused, but you have to have it somewhere, and you have to have access to it and let your team members have access to it so that they know what the tasks are, they know what the expectations for the completion date or the amount of hours that are required. So it doesn't have to be complicated, it just has to exist.
Any questions?
Software development lifecycle. So how many of you use the software development lifecycle? Whether you do or don't, you do. And what that's going to be is that's going to be code and fix, right? You think you know what you're going to do, you sit down, you start coding, you get halfway down, you say, oh, nope, that's not what I need. You back up and you fix it, and you go down another path. It's not as efficient as if you had sat down and you laid out, what are my requirements? How am I going to implement this? What is my architecture? You know, have you ever gotten mostly done with a project and said, oh, I just cannot handle this one corner case. The infrastructure I put together won't handle it. It just won't do it. And you have to go back and completely re-architect your solution. It's not a fun situation to be in. So there's lots of different software development life cycles. And to the question here earlier, you know, how do you define what your granularity is? So I'm going to skip around here a little bit. The spiral method, or the spiral development process, you kind of define a set of requirements. You implement that. Okay, then you define the next set. And so as you go through this spiral and you spiral outward, you are defining the smaller pieces of granular stuff. So originally you kind of defined a big process, and then you define that each iterative cycle, the definition gets a little smaller. So maybe up front it's boulders, but by the time you get down here it's pebbles. Does that make sense? So waterfall method, very common in regulated industry. Define your requirements, you know, implement your code, test your code, and every time you have to go back and fix a requirement, you roll back up and you waterfall back down. The V model is very similar to waterfall, but as you come down the model, as you move up the other side of the V, you start pinning it back and testing it back to your requirements and things like that. How many of you are familiar with Agile? Yeah, Agile is becoming very popular. There's a lot of tools out there that will support Agile software development. That's more like, okay, we define our tasks, and then we have a weekly or bi-weekly scrum, and we assign what tasks we're going to get done during that scrum. So you want to have the tasks small enough that you can get done with them in one scrum, one sprint, sorry. So you say, okay, I think we can get these things done with our parallel developers in this sprint. And so again, it's what you think you can get done in one sprint. So, questions about that? It's very important to have some kind of life cycle.
Would you recommend some kind of bibliography, maybe books, where we can go in deep with these models?
Okay, so the question is, are there any books or anything that I would recommend to to talk about software design lifecycle. Wow. Yeah, that is such a huge topic. I don't have anything in specific. I know that there's actually training courses you can take to actually learn these kind of things. There's even a certification, project management professional, but I don't have any one specific. You know, internally at Certec, we have our own little training module that we do about. We come from regulated industry, and so typically it's Waterfall, but we're really starting to embrace some of these other technologies, even considering some agile. We're kind of doing some agile stuff anyway, so we're kind of investigating that. So sorry I didn't have a direct answer, but Google, you're going to find all kinds of stuff. So I forgot my clicker over there, sorry. I don't know what to do without my clicker. So let's talk a little bit about software architectures. You know, obviously, when you start out a project, you could write the whole thing from scratch, right? We're all developers. We all think we know best. Sometimes we do, sometimes we don't. But you know what? We don't have to reinvent the wheel. There are lots of good architectures out there. Some of them are just built right into LabVIEW producer-consumer, you know, out of the box, create an example producer-consumer, queued message handler. How many of you have used Actor Framework? Yeah, Actor Framework's good stuff. Actor Framework, extremely complicated, okay? So it takes a little bit to wrap your brain around it. But after you get your brain wrapped around it, it's very, very powerful. I'll give you an example. I did a project, oh man, that's probably about 3 years ago now. And by leveraging Actor Framework, something that already existed, we were able to get the project done substantially ahead of time. Very happy customer. But it's because we didn't have to rewrite or create an infrastructure from scratch. Okay? So think about what's out there. Don't make it any more complicated than it needs to be. Don't use Actor Framework when you want to monitor 3 temperatures, right? That can be done in a much easier, simpler way. So just keep that in mind. And you know what? If you don't think any of the frameworks will work for you, that's when you might consider writing your own. Okay, but I would highly encourage you. JKI State Machine, that's a great one, you know, and they have standardized on that at JKI. I think they've moved over to the class-based version, or it's another option. But so just keep that in mind. So consider your project roles. How many architects in here? Great. Developers? How many of you are new to LabVIEW? Yeah, no, that's okay. That's great. Everybody starts somewhere. So consider that when you're laying out your project. Consider the roles that different skill sets require. Okay. So what you want to do is you want to have your CLAs define your architecture. How are we going to do this? Then come up with a framework that you're going to use, whether it's an off-the-shelf framework or whether it's a custom framework. And then give implementation details on how a developer might implement their tasks inside this framework. So if you're familiar with the CLA exam, that's basically what you're supposed to do in the CLA exam. You're given a task, you determine what the framework's going to be, you put in implementation details, but you really don't finish the exam. You just put in what is supposed to be done. So then your CLDs, your junior developers, they're actually going to be implementing the details in the code, okay? So remember that you need to provide feedback to them, okay? You don't just say, here, do this, do it this way. Get feedback from them. You know, make sure they're still on the right path, you know, they're not over here in the weeds. And sometimes during their development, you realize that maybe your framework wasn't quite right. And so maybe you do a course adjustment on the framework and give better details about how you think that should be implemented. Yes?
Do you give advice on frequency of providing feedback to junior developers?
Frequency on providing feedback. That's a great question. I think it kind of depends on the developer. A much younger, much more junior developer might need more attention than a little more seasoned developer. Again, I'm answering questions with vagaries. I apologize for that. But, you know, so much of this stuff depends. You know, I would say you at least need to have statuses at a minimum once a week, depending on the magnitude of the task. So if it's kind of a, I want to say, kind of a turn the crank kind of task where we just need somebody to punch out code that does this, maybe it's not as often. But if you're having to develop new ways of doing things, and things that have never been done before, maybe it's once a day. Maybe it's, you know, hey, call me when you get stuck. So yes, great.
Often you try to establish templates or coding standards during that process with developer versus architecture.
Okay, so the question is, how often do you establish templates or a coding standard? So a coding standard in general, we're going to talk about that. That's up front, got to have it. As far as templates, I'll give you a good example. Let's say you're doing a class-based project. Basically, the CLA might establish the base class and then establish what a child class looks like. And so that's a great template for junior developers to take. Hey, just basically copy this class, implement these methods. So that's a great way to do something. Anyone else? Great. Task tracking. Okay, so Paul's done a good job of laying out, you know, that we should have tasks. We should know what those tasks are. But I believe that you should track your time towards those tasks, okay? And by doing that, you can get a metric on what these tasks are actually taking, what kind of effort they're taking. Now, remember that when you're doing a task, that percent of hours consumed does not equal percent complete, right? You would think, well, duh, but you know, how often have you gotten the hours consumed on a task and realized you're only half done? And that's when you got to go to your manager or your project manager and you got to say, we're in trouble. The flip side also happens, you know, I've had it before, hey, I'm like done and I'm only through half the hours. Now, that's not the typical case, but sometimes it does happen. So I think it's also important that you evaluate those tasks at the end of a project. Okay, so this task we thought was going to take 100 hours. It took 200 hours. Why? Okay, was it a technology risk that we had? Was it a schedule risk that we had? The other thing is sometimes you need to consider your developers when you assign these tasks. You know, some programmers are really fast and they just crank through code and they get stuff done. Some programmers are just a little more thorough, right? They really contemplate what they do. They really process it. So keep that in mind when you make your task assignments in the future, and when you estimate those tasks in the future. Paul always tells me, don't estimate it like you're doing it. Estimate it like an average person is doing it. So
Maybe,
yeah.
if you break down the task, maybe that will be more accurate to estimate the tasks beforehand, isn't it?
Right. So the comment is, the smaller you break down that task to, the more accurate that estimate could be. And I think that's legit.
Dovetailing on that, I've heard of one technique where you break it down so tiny that a task is either done or it's not. And it avoids this I'm 90% done thing. I mean, almost everything's always 90% done, right?
With the other 90% yet to finish.
Yeah.
10% of the work takes 90% of the time, right? Okay, so the comment was, if you break it down small enough, it's either done or it's not, right? And so it's really, you don't have this, well, I think I'm 90% done. It's either done or it's not. You know, and it's a hard thing to do, to know how far down to break something. You know, like we talked about the class-based stuff, you could say, implement this class, and when you're done, the task is done. You know, depending on how difficult that you know, if it's a class that takes one day to fill in all the methods. I'm thinking of a messaging architecture where every different message is a class. Maybe that takes a day, and it's either done or it's not. Or you could say, I have 5 of the 12 methods implemented, and that would be an easy metric too. So, but yeah, it's a good point.
I think a lot of times that's kind of setting expectations, right? It's setting management's expectations of how much longer do you think this is gonna take, right? So would it be better to set a new estimate on how much more work needs to be completed?
Okay, so let me see if I can paraphrase that. Should you adjust expectations on the fly? So if you've consumed a certain, yes, absolutely. So let's say you get into a task and you think it's going to take 100 hours or 40 hours or whatever the number is. And you get into it and you're like, wow, this is really a lot more complicated than I thought it was. Either you missed identifying it or it's just, sometimes it happens, it is harder. So yes, I think that needs to be brought up. You need to adjust your schedule. And a lot of times if it's a real big variance, you may have to take that back to your customer and say, this is a lot harder than we thought it was going to be, and that either adjusts your time frame or could adjust your cost schedule. So that's a good point. Yes?
You mentioned done a lot. Could you comment on what specifically done means for your group?
So what does done mean? That's a good question. So for a developer, done would mean that I've looked at their requirements, I've implemented the code, I've tested my code, okay, for the developer. But now there's this process where you need to go through, and it's kind of stealing the thunder of another slide.
No, go ahead. Then we'll wait.
Got to do a code review. Got to do a code review. And so, speaking of which, thank you for that segue. Code reviews, super important. So what's the first thing you have to do a code review? A coding standard, yeah, it's kind of up here, it kind of gives it away, doesn't it? You gotta have a coding standard, and whether that's a real simple coding standard, like block diagrams don't go bigger than one page, or anything like that. Yes?
It's something I guess I kind of struggled with. How do you do a code review when you're the only LabVIEW programmer in the whole damn building? By the way, I only write code for that building, for our company.
Okay, so the comment is, how do you do a code review when you're the only developer? Did you have a comment on that, or?
Yeah, I was gonna comment to that, but also push back a little bit on coding standards. We've found immense value in doing code reviews, even without coding standards, even if the person you're reviewing with doesn't know anything about LabVIEW. The act of having to explain what you did to anybody is really valuable, and we found that it's really effective at working through bugs, identifying bugs. So talk it through with anybody.
You can even just explain it to your cat. You can't explain it to your dog because he thinks you do everything perfectly.
I think the concept's called rubber duck programming. Like if you talk to a rubber duck on your desk.
Yeah. Kev?
I just want to bring up the coding standards and code reviews. The VI Analyzer is a really useful tool to do kind of audit yourself.
Yeah, so VI Analyzer, good tool. It'll tell you whether or not you had your block diagram too big. It'll tell you whether or not you can actually create your own little things for your own coding standards and stuff like that. So that's a really good point. As far as not having a coding standard, your coding standard is not having a coding standard. So.
I'm curious what you think about when to do the code review. In other words, I've heard that you actually do it before they started debugging. So basically the code's done, then you do the code review. And I've seen where you don't do that, and it's a problem because the person says, you start pointing out, well, this might go wrong. Well, I've already tested, it works. And then they're not interested in really listening.
Right.
But if you do it too soon, then everybody's basically a compiler. You're all finding the stupid things that.
Right. So the comment really is when do you do a code review? Is it just when you finish writing it, when you finish debugging it, when you unit tested it? When is done? Well, when do you review that? It kind of goes back to when it is done. So yeah, it's going to vary. I agree. I would like to know that it's been functionally tested before I did a code review, because there's so many little things that you miss that, oh, I was building this string and I forgot to put a space in there.
Right.
Yeah, that's an overly simplified example. Yeah, so it's a great question. It's a great
And how do you
question.
combat the, well, I've already run it, I've already tested it and it works, and they just don't really want to listen to.
Yeah, so the developer could get this mindset, well, I tested it, it works, I tested it, you know, so it's done, or it's good. So, yeah, that's a good point, and I think you really have to communicate with the developer that, like that.
Let's review the requirements.
Yeah, let's,
Go back to requirements and show that they've been fulfilled.
so speaking of requirements, what's the second thing you have to do a code review? You have to know what that code module is gonna do, right? Without requirements, how do you know it's doing what it's supposed to do? You don't. You say, well, I wrote this code module, and it does something, and it works, right? It works, because it runs, it compiles, it runs. But without a set of requirements, you really don't know that it does what it's supposed to do. I would encourage unit testing. So you have a set of requirements on what this thing's supposed to do. And sometimes it's throwaway code, right? I think of it as throwaway code. I'm building a code module. I drop that code module into a VI. I run some tests on it, and maybe I throw that VI away. Well, I think it might have been Jim Crane went to one of his sessions once. They said, don't throw that code away. You're unit testing your code right there. That has value. Keep it and make it kind of a unit test. So like I'll create a utilities folder inside my LabVIEW project, and that's where I'll dump my throwaway code that's really unit test. Let's remember that when we do these code reviews, we're also mentoring our junior developers, right? And we can actually be mentoring each other. You know, if you have CLDs reviewing each other's code or junior developers, it's an opportunity to mentor those guys. You know, we want to bring them up. We don't want to break them down. We don't want to say, why'd you do it that way? A technique I like to try to use is kind of explain to me what your thought process was when you wrote this code. You know, explain to me how you came about this method or this algorithm that you're doing. And if they can't explain what they were thinking, then maybe you need to walk them through it. Because maybe you can look at it and go, I don't think that does what you think it is. So, but again, we're not there to break them down. We're there to build them up and make everybody better developers. I think I was going to trip over that question.
Does documentation also needs to be part of the code review?
Does documentation need to be part of code reviews? My code's self-documenting. Yeah, I would encourage to check documentation, especially if a developer can't tell you why they did something. Like, well, I know I had to do it. Well, then maybe that's a good chance for you to document why you did that. Now, I assume you're talking about code documentation, not requirements, which should have already been done.
Requirements as a folder.
Right.
On the actual design specifications, how you build up your code, so.
Right.
As each task, you already want to describe what you did.
Right, right, and so that can also be part of your coding standard. Like, you know, all code that's not completely obvious what's happening needs to have a comment. And I know that's a little bit nebulous, but it's a great idea. Yeah, that's great feedback.
Okay, so we've covered the project plan, work breakdown structure. We've talked about LabVIEW architectures. Now let's talk about the implementation and control of the project and monitoring your progress. Try to avoid pitfalls. So for example, oftentimes we run into a problem where we don't have all the information that we need. We've got a set of requirements, but you get into some implementation specific details that you need input from somebody else. And it's frustrating sometimes when you send emails and you leave voicemails and you can't get a response. So my encouragement is to be a squeaky wheel. Just be persistent, keep annoying them, and finally hopefully you'll get the information that you need.
Sometimes maybe you need to elevate that.
Escalate to management.
Yeah, we've been asking for this, and we haven't, and sometimes it's you mention it in passing to their boss. Yeah, you know, we're kind of still waiting on this, and sometimes it happens pretty quick after that.
The other thing to try to do is eliminate non-essential or inefficient activities. At Surtech, we're a small company. Each of us wear many different hats. But if there are times when you can delegate fabrication work or drafting activities, delegate that to a junior member of the team. Also, when you're troubleshooting, this is kind of a delicate area, but because because we all like to try and solve our own problems. But there comes a point when you need to get the input from somebody else. And like the review comment, sometimes when you just describe the activities that you've done for troubleshooting, a light bulb kicks on, oh, but I didn't try this. Or if Ryan's reviewing, if I go to Ryan and say, here's what I've tried, do you have any suggestions? Just a couple questions that Ryan might ask may trigger that solution. So you could spend a day, a week, a month trying to solve a problem, but after you've been in just an hour or two, seek some help from somebody else.
Yeah. How many of you have been explaining something to someone else, like, this is the problem I'm having, and you go to that one spot in the code and you go, never mind. Yeah. Been there, done that. Yeah.
So manage your time daily to maximize productivity. Again, look at the work breakdown structure and look at the tasks that you're working on that are assigned to you, and be focused on those to keep your project work on track. Communicate regularly with project team and stakeholders. So for large projects, you want to have a communication plan. How will project information be disseminated? We talked earlier about hitting that 90% point and we're not done. Regular communication will help with these issues. It's a time, we recommend doing weekly status reports from our team members, and that's a place to show progress, which planning to work on next week, but also, what are the obstacles to my progress? What information do I not have? What problems am I having? I need help from management or somebody else from the team to keep things moving along. And then consider a risk management plan for larger projects. How will risk be identified, quantified? Maybe you've got a risk log that you track. Store that in Subversion. That's what we do on our projects. And discuss those at meetings and talk about the progress that you're making on those items, and hopefully you'll get those resolved.
So how many of you use some kind of revision control system? Yeah, if you're not, you should be. So, it can be used for code, but it's also good for things like, these tracking logs and things you've asked for, getting feedback from customers. And, we talked about these status reports and listing obstacles. If you see that same obstacle popping up week after week, maybe it's time to escalate.
Project management experts recommend that you communicate these different areas, information about project status, work status, tasks achieved, upcoming tasks, obstacles, any areas of risk on a weekly basis. So you don't want to go a month and then find out, oh, we're almost out of money, or we've got big problems implementing a certain technical solution. And you want to keep all the team members in the loop on these communications. That's why it's important. We do the weekly team meetings to help with the big projects, keep everybody in the loop of what's coming up next and who's responsible for which piece. I think about, we get to the end of a project a lot of times, and there's a hero's effort to work tons of hours, weekends, to try and meet that end milestone date, project date. If we can have that kind of intensity and focus at each of the interim milestones, conceptual design, detail design, fabrication, software, you spread that out. And if you're focused and meet those dates, that makes meeting the end date a whole lot easier. So that's something that we really focus on, is the major milestones on the project. We work with that intense focus to meet those dates, and then you get to the end and it's a lot easier to complete the project on time. So again, we've talked about managing project risks, have a risk log to track potential events, identify, quantify, qualify. We had a project where our test system interacted with a centrifuge that was provided by another vendor. And we were concerned that the centrifuge would not be delivered on time to support our project schedule. So that was a risk that we identified early on, and it came to pass. We did not get the centrifuge on time. So we created a box, we called it Pretendifuge, and it emulated the unit under test, and we had switches there, so we could run our test sequence, hook up all the cables to the unit, to this centrifuge, as if it was in the centrifuge to do the testing. So when we finally did get the centrifuge delivered to our facility, we were able to quickly get our testing completed. Again, communicating risks to the stakeholders and making them aware. We kept our client in the loop on the delays that centrifuge was causing us, and we tried to get their management to escalate and get it to us sooner, but it wasn't our fault.
So I'll add just a little bit about risk management. Risk management is not just kind of in line with your project. It needs to be evaluated up front, before you even start the project. And I'll give you an example, or just kind of give you a reason why I think that. If you're doing a fixed price, especially if you're a contractor to another organization, if you're doing fixed price and there's a lot of risk, you don't want to be stuck eating all those risks. You know, hey, this didn't happen the way it was supposed to. We knew it was a risk, and so we're going to have to eat the cost of that. You need to identify that up front. Maybe you put in a risk mitigation buffer inside there that, you know, hey, if you want me to do this fixed price, you have to understand I have to charge you more because of these unknown things. So otherwise, you have to renegotiate in the middle and say, well, we kind of thought this might be a risk, but we didn't say anything. It's going to cost us a lot more money, and now you need to pay us. Customers don't like that. They would. So, and again, if you're doing time and materials, and it's going to take you a lot more time, you got to renegotiate. You know, you got to let them know why you're not meeting the schedule. We identified risk up front. We told you this might take more time. It's true, it's taking more time, so we need to renegotiate our arrangement. Yes, sir?
I've had, okay, so good project management 101 is you identify the risks first and you work on them, you know, you focus on those first.
Right.
I had an employee who was extremely good at that. So, and he was a very senior guy, and be good for project management, but we could not bring him along on a sales call. Because all he did is point it out to the customer, well, we might not be able to do this, and that's gonna be hard, and
Right.
really shake their confidence. But how do you, if you want him to be the project manager, you really ought to be in on that first meeting or those early meetings, so he knows what the heck he's managing.
Right.
So how do you handle a situation like that?
Okay, so here's the comment in a nutshell. You got a guy that's really good at identifying risks, but he's terrible on a sales call because he's telling you about all the risks, right? That's pretty much sum it up.
Yeah.
You know, I would put a buffer in there, and this is just my, you know, on your first initial meetings, you know, maybe don't take him. Do kind of a reconnaissance, get your information, bring it back, find out what all the risks are, evaluate what are the biggest risks, and then take those to the customer. And, you know, everybody could look at that and just say, oh, that's not going to work. You got to do all these things. And sometimes that's the pessimistic view. It's really not going to work out that badly most of the time.
Right.
I think a good buffer, it's great information. You know, you definitely want to keep this individual in on the loop, just maybe not in on the sales call.
I'm gonna stick up for your man. I'm a buyer of capital equipment projects.
Okay.
The companies I stay away from are the ones that are very agreeable, polite, and nice. The ones that I like to deal with are the ones that have jerks. They have a nice guy, but they also have a jerk.
Right,
They'll keep
right.
pointing out, well, here's some of the things I see. And then they'll require me, I don't want sample parts from just one lot. I want sample parts for the last 4 months, 6 months preferably.
Right.
And that's the company I know I want to deal with.
Yeah.
So I'm gonna stick up for your man.
Yeah. So the flip side of that argument is if a vendor is too agreeable, maybe they're not really evaluating the task at hand. And so maybe if they are pushing back, you know, we've got all those personalities inside our organization. We've got the eternal optimist and we've got the eternal pessimist, and there's got to be a realist somewhere in the middle that you can, you know, be a realist. So yeah, it's all great feedback, and I think if they are the eternal pessimist, maybe we'll kind of hold those in reserve and buffer them. So, yes, sir.
Yeah, it seems to me that the biggest risk in our organization is disruptions. You know, I'm being asked to do this thing, I start working on that, now I get asked to do something else, then something else, and it may be months before I can go back and finally finish the one thing that I was asked to do.
Yeah, okay.
Interruptions that always is the biggest risk.
Right, so the comment is, you know, a lot of developers, especially good developers, are pulled in multiple different directions. And how do you handle things like that? You know, first of all, making management aware that, you know, I can only do so many things. And there's only so much time in a day. Having a good, you know, we track resources, internal resources, staffing resources, and seeing how many different projects that are assigned to them. You know, sometimes some developers need to be single task. Some can handle multitask. I task switch really well, but not everybody does. And some people take, you know, days to task switch. How do I get my mind back engaged in that? And so I think it's something you need to evaluate on an individual by individual basis and say, okay, this guy seems overloaded and can only focus on one task at a time. So we're gonna say, do this and get this done and do this well, as opposed to just throwing more stuff on them.
And it may take management to say, you know what, we're gonna leave those interruptions, those are lower priority, stay focused on them, get that task done, and then work on those interrupts, work on those other items.
Well, and I have a tendency to kind of make myself a part of everything. You know, I like to be involved, I like to mentor, I like to help. And so that's something I need to be aware of, is that, okay, I need to focus, you know, I need to spend a week with my door closed and try to get work done. And some people can recognize that that's happening, some people can't. And so if they can't recognize that they're overloaded and they're not getting the work done, then let's reduce their task switching responsibilities.
Okay, moving on. We've talked about scope creep. You want to manage that, stick to the requirements. We've talked about the nice-to-haves, but especially for fixed-price projects, you want to get paid for those nice-to-haves. So bring it up with purchasing, get the approval from the purchasing agent, describe what the situation is. I think the good plan is to talk with the engineer, talk with the engineering manager, pitch the idea of here are the items that are scope change, and then they can take that to purchasing and get the authorization to get a change to the purchase order to get increased funds. And the other thing to consider is sometimes those scope change items delay the project completion date. So maybe you can work them in, work things in parallel, but if not, that needs to be negotiated as part of the change to the contract, a change in extending the delivery date for these extra items that you've requested and are willing to pay for.
I have a question, maybe from the business point of view. Would you think it will be smart to talk with the customer and say, let's reserve some spare of budget for nice-to-haves or change of scope, and if those nice-to-haves or scopes are not implemented, I will return this spare, because it's always easier to return a non-used budget than ask for additional budget if something was not considered beforehand.
So the comment was, is it a good idea to basically add a buffer for nice-to-haves when you go to quote something with your customer? You know, that's, I mean, I've got a comment. You got a comment on it?
Not really.
Okay, so something I've been considering lately is there's always something we miss, okay? You do your due diligence, you put together your estimate, you think it's gonna take this, and then you find out that this piece of equipment doesn't come with cables, and it's gonna cost you $100. And you think, well, it's $100. Yeah, but you do that enough times, and that starts to add up. And so this concept that I'm thinking about is, tell your customer, this is what it's gonna cost to do this work, but I'm gonna request for you to request 10% more. We're only gonna charge you this, but I'm gonna ask you to request 10% more. Because you're right, requesting budget once is easier than continually going back for project scope changes. So by doing that, it kind of streamlines the effort of getting a little extra money. and you've warned the customer up front that, hey, you know, I'm doing this fixed price, there's a little bit of risk here that I'm not gonna charge you for. We don't have that problem with that risk. And if we do, we just do a little addendum, we have a little more money. But make sure that they understand that we don't intend to charge you this, but it could be up to this much more. And then you could theoretically take that budget and do the nice to haves.
So time check, we've got 3 minutes to do 2 more slides. So
We can do it.
talking about testing the deliverables, Certec, we do a lot of requirements-based testing to do verification and validation of the systems we're working on. So testing out your deliverables is very important. Getting user acceptance on the completion definitely, and sometimes different phase gates you need customer buy-off. So a lot of times on conceptual design and detailed design, we have customers in the meetings and we come up with action items that come out of that design review of what we all agree the final system should include. Outline a testing strategy and work within that strategy, and then ensure that the project developers are communicating with the project testers. So many times we're doing independent quality control on software that's developed. And so early on in the process, the requirements are being vetted and the software developers are working on the code. We're developing our test scripts, our test plans, and hopefully we can identify defective requirements early on in that project. So if we're communicating with the software team, that's a very good thing. A good thing to happen. But basically, we're near the end of the project. We get sign off, we get everything tested out, and you get buy-off from the customer. That's kind of your ultimate goal. Hopefully you've done it on time, within budget, with a full feature set, full quality. But there's one more thing we want to do, and that is to evaluate the project. At Certec, we do lessons learned projects on the larger projects to get the team together. It's a safe place. It's not a blame type of situation. It's we want feedback. What did we do right on this project? What did we do wrong? What parts took a lot longer? What did we miss when we were estimating this project or budgeting for it? Let's find out how we did on this project and how we can improve on the future. Many times, I oversee our quality system at Certec, and so I will take summaries of these lessons learned meetings and then distribute them to the team. You can put them on a website, put it on a wiki page or something like that. And the key thing is, you can use that information then to better estimate the next project for all these different factors. Risk, software implementations, those kinds of things. So, just wrapping up, we've talked about the project plan. The work breakdown structure is key for guiding your daily activities for the team. Keep it updated. It's a living document. Add items, subtasks as they come up to make sure that you've got all of your functions, all the requirements covered. We talked about LabVIEW architecture, different possibilities. And then monitoring, controlling, and I think communication is key. If problems come up, don't wait. Bring them up as early as they come up and keep management, keep your customers informed of the progress. And I think the difficult information will be easier to swallow if it's brought up earlier and they know what's going on.
Questions?
I just wanted to add, somebody asked about resources a little earlier. I would suggest there's a man named Michael Jackson, not the singer, who has done some really great research into requirements engineering. And then there's Brooks, Brooks typically man is like reliable or like project management.
Great. No, that's good feedback. We're over time now. We'd love to talk with you guys. Love the interaction, love the feedback. Don't forget there's a survey. If you've got more questions, just come up and grab us. There's a presentation right after this about onboarding new employees. Yeah. So I think it kind of plays right in from this one. So thank you for coming.